Hi guys, this week we're going to look at chapter 7. It's all about exponents, exponent laws, and exponential growth and decay. We'll just basically go through the basics, broken down into 3 days or 3 sections. I'm going to double up on some sections because some are a little bit shorter. And then chapter 7 will be due at the end of the week. Okay, so this is a review from grade 10. It just says that if you have a base to an exponent and you multiply it by the same base to another exponent, the exponent law tells you to add the exponents. So you just go m plus n. If you divide powers, exponents with the same base, you subtract the exponents to get the final answer. And this is called a power of a power. So if you have a power and it's taken to another power, you multiply the exponents, m times n, to simplify the expression. Okay, 3 quick examples. So if I had 5 squared and I did it to the power of 4. So you could do it very easily on your calculator, but here's the rule. It's a power of a power, so you multiply the powers. 2 times 4 gives you simplified to 5 to the power of 8. So some questions are going to ask you to simplify. Some are going to ask you to evaluate, and I'll show you that in example 3, what to do if they ask you to evaluate. Okay, this one is 3 to the power of 4. Touching 3 to the power of 8, so that implies multiplication divided by 3 to the power of 7. So you take the 4 plus the 8 minus the 7. That's how you're going to simplify the powers. 4 plus 8 is 12, minus 7 is 5, 3 to the power of 5. Okay, this is a more complicated one. 6 times 6 to the power of 7 divided by 6 to the power of 3, all squared. So this 6 by itself means it's power of 1. Still, so you got to go 1 plus 7 on the top to make 8. 3 times 2 on the bottom to give you 6. 8 divided by 6, you subtract the exponents to get 6 squared. So that's what it looks like if they ask you to simplify. If they ask you to evaluate 6 squared, you just do 6 times 6, which is 36. Okay, so simplify or evaluate on those. Okay, a few questions. 399, 1 to 3, 5 to 7, and 9. So that's 7.2. We skipped over 7.1. It was just a basic investigation. Okay, moving on to 7.3, working with integer exponents. Integer exponents just means negative exponents, or it could be to the power of 0. So here's the 3 basic laws. So if you have b to the power of negative n, that's a reciprocal. So a reciprocal just means you turn it into a fraction. So you just do 1 over b to the power of positive n, and you should know, based on the last section, how to do b to the power of positive n. If you have a fraction to the power of a negative exponent, all you do is flip that fraction, and the flipping of that fraction makes the exponent positive, and then you go forward and solve. Okay, and the third one, anything to the power of 0 is equal to 1, whether it's positive or negative. That whole thing to the power of 0 equals 1. The only exception is if the negative is not contained in a bracket. That would be a result of negative 1, because you would do a to the power of 0 first, which is the 1, and then you apply the negative, because exponents come before multiplication in BEDMAS. Okay, 3 quick examples. So if I had negative 3 to the power of negative 4. So first thing, I want to get rid of that negative exponent. So I go 1 over, and that process gives you a positive exponent. So it's negative 3 to the power of 4, which means negative 3 times negative 3 times negative 3 times negative 3. Which is 81. So that is 1 over 81. This fraction to the power of negative 2, flip the fraction, it becomes 6 over 5 squared. 6 squared, 36. 5 squared, 25. So this is actually 36 over 25. And then one where you combine all those first and second sections. We have 5 to the power of negative 4 times 5 to the power of 8. So you're going to add those to get 5 to the power of 4. And 5 to the negative 3 to the power of negative 2, you're going to multiply those to get negative 6. And now you're dividing powers with the same base, so you subtract. So you're going to go 4, subtract negative 6. The subtracting negative 6 turns into 4 plus 6, which is 5 to the power of 10. Okay, so those are your integer exponents. Page 407, 1 to 6, and number 11. Okay, and again, I'll be online for any questions. Have a good one.